Hello everybody, welcome back to the screencast. In this video we are continuing where we left off with the sequence diagram, and if you haven't checked that one you can do so by clicking on the top right corner. And this one was supposed to be everything about the mocks, but I realized that I want to expand on the topic a little bit more, so let's name this test doubles. And here I've prepared a list of test doubles that are known today in the industry. We have dummy, then we have stub, which is sort of dummy, then we have a spy, which is kind of stub, and we have a mock, which is kind of spy. So they are all in a way related. And then on the other hand we have fakes, and we are going to use the fakes throughout this whole exercise pretty extensively, so I will leave them for later. And the goal of this video is to make sure that we see all these other different kinds of test doubles, how do they look, when do they make sense to be used, and so on. Now before we start, I want to point out that many people today are using the term mock to refer to different type of test double. Now that's not necessarily bad, but it may create some confusion. And I hope that this video will bring up the awareness, and we're gonna end up with more efficient communication later on. So when somebody says let's mock this out, or let's use mock, they may not necessarily mean an actual mock. They may mean of different kind of test double. So we have to be aware of that. Okay, so now let's go ahead and create a class here. I'll name it test doubles, and I'll write a new test here. So let's see what we have. For the sake of this example, let's suppose I have an interface that has a function which takes string, it would return boolean. And so this is pretty simple validate function. And then let's assume that we have a class. I'll name it system under test that would inject the validator. Let's also suppose that here we have a function that returns some sort of state. Now this is only for the sake of simplicity. I'm going to use primitives, and we can just assume that this function may do some complex inside, may call other collaborators, but let's keep it simple for the sake of this example. Now here in the test I want to test the public API. So I'm going to start with the assertion, and I'll do public API we want to test. Let's import and create system under test. Now I want to instantiate the system under test, and I need to pass there a validator instance. But I see that the public API we want to test, the actual function, is not making any calls to the validator. And the first test double that comes into play in this situation is the dummy. So we would create a class that would derive from the validator. And here, if I leave this to do, it would throw an exception, but I want to be more explicit. Throw illegal state exception should not be called. Right. So this is a dummy. Then I can use the dummy here. So now, because the public API we want to test is not making use of the validator at all, the best thing I can supply there is a dummy. And the part of the responsibilities of the dummy is to make sure that the functionality of that collaborator is not being called. So if somebody calls validate, an exception will be thrown. And that's the actual point of the dummy. So the key point here is that the name dummy here is not making this class dummy. What makes it dummy is this behavior here. And now if I run this test, it would pass. And the idea is that if I make a call here to the validator, it's irrelevant what we are gonna pass there, but it should fail. Yeah, so in Java it was pretty common to actually return here a null. So if we happen to use to make a call to the validate function in the system under test, we would end up with a null pointer exception. That's the goal. Okay, so that's about the dummy. Now let's take a look at a stub. So let's go ahead and create a class. Again, we would derive from validator over the validate and return. So we're gonna hard code here a true. So because this is a passing validator, it would always return true. Now, if, for example, the system under test that needs to make a call to the validator, but it's not part of what we are testing at that moment. What we really want is, let's collapse this one so it would make more space. Yeah. So we need the validator to always pass the validation regardless on the actual argument. Let's suppose that we need that, and here, for example, if we had return if validator validate, then okay, else not okay, something like this, then here we would pass a passing validator and it would work. And now if we want to test, for example, we have another test that we want to test the other scenario, then we would create another stub which is like non-passing validator, and of course it would return false here, and we would use that one to verify that the other state is actually produced. So that's about the stub. Let's look at a spy next. Again, we are deriving from the validator. And now here we would return something that we are able to configure. Let's say that we have a property, it should be a variable, and by default is, let's say, false. We need to be able to configure the behavior. And another thing which is common for the spies is that they are spying on the actual calls. Something like, for example, we have a variable was validation called, which is by default a false, and when somebody calls this one, was validation called would be true. Now, as you can imagine, we may actually save those calls in a list with like different arguments, and then we can see if the validate was called with particular argument and so on. But this is the actual essence of the spice. And now if I use here the validator, and I would create an instance of it, SPI validator, I need to be able to configure it. And then we create an instance, and I would pull this one out as well. So this would be result. Oops. Sorry about that. Right. So again, we have an assertion here, but most probably when we are using the validators, we do also the assertions. We need to make assertion that a validator was called. Something like this. And now let's run. And of course it should pass. So yeah, so that's about the spice. So they basically keep the information, what was called, which arguments were passed, and that kind of stuff. And ultimately, let's look at the actual mocks and how do they look like. And once again, I want to point out the name is not making the actual test double what we are naming them, but the actual behavior. So if I name this a mock, it won't make it mock. It's still a spy. And here, if I let's look actually how the mocks look like. So the mock is very similar to the spy. We also should be able to configure it, but a key difference is that they are not exposing the actual spying mechanism, but they expose functions, something like verify validation was called, and they do the actual assertions inside. What's validation called? Something like this. So it would expose a function and it would do the assertion itself internally. And how do we use this? We are using it like this. We make instance. Of course, it has to be configurable. And here we do the validator verify was called. So that's the actual difference between the spies and the mocks. The mocks are doing the verification themselves inside. Now, as we saw, now we looked at all the different types of, all the different kinds of test doubles, and they all have specific usage. They can be used at different places. And the key point of this video that I wanted to make is that when the mocks are making sense, and when do I use them. So the first thing is that I see the mocks as a design tool. So I use them only when I do outside in TDD. So they make sense to me only when I'm doing the outside in approach, because I use them in order to emerge design. So I end up with very little mocking, and I'm not ending up with coupling the production code with the tests. But I don't see much sense of using the mocks when doing the other approach. So this series is planned to be, now first we are gonna go through the search functionality exercise using outside in, and we are gonna use mocks so we can see how actually we are gonna do the design. So as described here, how we are actually doing the designing using the mocks. And then as a continuation, we are gonna redo the whole thing using the inside out approach. And then we will see that in that case, the mocks are not making much sense. So as I said, when we are doing the inside-out approach of test-driven development, or if we are refactoring a legacy code and we are writing tests for a code that already exists, most probably we are not gonna write a single mock. We are not gonna use a single mock. Now, there might be some situations somewhere, some extremes, when a mock might be needed, but that's gonna be very, very rare. So the usage of mocks is gonna be close to zero. So that's why I'm saying they make sense. I'm using them only as a design tool, not as a substitute regularly as I go. So I think we can declare a victory on this one because we went through the test doubles. I hope that this video was helpful and it would at least help you understand all the different kinds of test doubles, when they are used, how they are used, and so on. In the following one, we are gonna look at we will start working with the actual code, with the actual exercise, and we are gonna see how we use mocks for designing and how the outside-in TDD approach looks like. And at the very end, I want to say that for mocking, at least I cannot talk about all the languages out there, but I can at least speak for the JVM languages. There are libraries that we use for mocking, and I want to actually say some words about when they are good, when they are bad. So what are the pros, what are the cons? The actual pros are that as we go, we want to make sometimes we want to mock out or spy on types that are actual classes. Now in Kotlin, for example, everything is final by default, and if you want to make a mock of a class, that's not very possible. If you want to do something like derive it ourselves, so writing a manual mock won't be possible, or we'll have to use the all open compiler plugin, but then we would have to create a custom annotation, then sprinkle that custom annotation all around our code. That's very nasty. And the other way is like if you are using Mockito, the very naive way to be able to mock concrete types is by using this Mockito plugin, which looks like this. And then if I mock out a concrete type, it would work. But now what are the cons is that when we create a mock out of interface or concrete type using a library, during the compilation it would have to create that for us. So this sort of thing, what we have here written manually, would be created by the library, and that takes time. So for example, when we have, like, I don't know, some tens of tests, we won't see much difference. But when the test suite will start growing, like above 500 tests or thousands of tests, then it will take significant time to run all the tests. And if you compare mocking, like this kind of mocking, like manual mocking, as we saw here, the test ran pretty fast, actually 30 milliseconds. I mean, it may differ, but it's a really small amount of time. However, if I use Mockito or Mock-K, it would take significantly more time, especially if I use Mockito with the Mockito plugin, compiler plugin. That's gonna be really a lot of time. And then as the test suite grows, the time to run all the tests will grow significantly, even maybe exponentially, as we are going up and with the test count, and that would slow down basically everything. It slows down the feedback cycle, it slows down the TDD process, it slows down the continuous integration systems, and so on and so on. So the moral of the story is that whenever you can do the mock yourself, when for example you have an interface like this example here, write the mock yourself, write it manually. Or if you have concrete types, as we're gonna see throughout the exercise, it might make sense to actually use some mocking library, but take a look at like some benchmarking or something like that, or do the benchmarking yourself and see what works better for you. That's gonna be it for this video, and so in the next one we are already starting working with the code in the test in the outside in approach, and till then have a good time.